We begin this chapter with kinematics language for describing rotational motion. You will find that for every term in kinematics that you are familiar with, there is an angular counterpart, angular position, angular displacement, angular velocity, and angular acceleration.
Angular position. The angular position is defined as the ratio of the arc length, s, and radius, r, of the corresponding circular path. From Figure 6.1, angular position or theta is given by this equation, where s equals length of arc, r equals radius of the circular path equals angular position. The SI unit for theta is radian rad. For a complete circle, 1 revolution is equal to 360 degree and 2 pi radian. Angular displacement. The angular displacement is defined as the angle turned by the disk about a rotational axis. From Figure 6.1, if the disk rotates from the angular position by 2 the angular position f, the disk undergoes an angular displacement given by this equation. Angular displacement is equal to angular position f minus angular position by angular displacement can be either positive or negative. It is positive if the rotation is in the counterclockwise direction and is negative if the rotation is in the clockwise direction. The SI unit for angular displacement is radian or rad. Angular velocity. The angular velocity is defined as the rate change of angular displacement. The symbol for angular velocity is a Greek letter and we pronounce it as omega. From this Figure 6.1, if the disk rotates from angular position I at Ti to angular position F at Tf, the average angular velocity of the disk is given by this formula. When change of time is approaching zero, the instantaneous angular velocity, or simply said as angular velocity, is given by this formula. Omega can be obtained by differentiating angular displacement with respect to t if the function of angular displacement is known. Omega also can be either positive or negative. It is positive if the rotation is in the counterclockwise direction and is negative if the rotation is in the clockwise direction. The SI unit for omega is radian per second. Angular velocity of all points on the disk is equal to each other since the number of rotations per unit time is equal. The magnitude of angular velocity is angular speed. For a complete circle, omega is equal to angular displacement over change of time, or 2 pi over t, or 2 pi f, where t is period, that is the time taken to complete one circle. The SI unit for t is second. Meanwhile f is the time taken to complete one circle or one revolution. The SI unit for f is hertz or per second. Angular acceleration. The angular acceleration is defined as the rate change of angular velocity. The symbol for angular acceleration is also a Greek letter and we pronounce it as alpha. If the angular velocity of the disk is not constant, the disk has angular acceleration. Let omega I and omega f be the angular velocities at time initial and time final. The average angular acceleration of the disk is given by this formula. When change of t is approaching zero, the instantaneous angular acceleration, or simply said as angular acceleration, is given by this formula. Alpha can be obtained by differentiating omega with respect to t if the function of omega is known. The SI unit for alpha is radian per second square.